1.5 billion miles out in space and arrives at Jupiter, the giant of the solar system. With a planet twice as massive as all the others combined, Cassini's cameras face their biggest test yet. Jupiter's majesty is revealed as never before. Its swirling gaseous atmosphere is seen with breathtaking clarity. But Cassini has to move on, across another 500 million miles of space, before it reaches its final destination. For imaging team leader Carolyn Porco, the Jupiter pictures are a triumph. But her true goal is the planet she has devoted her career and heart to studying: Saturn.
To know that we can know so much about our solar system and about our cosmos, for me, makes life meaningful. It's very much like being in love. It's very much that kind of a relationship where you want to know more and you want to be one with, you know, the person you're in love with or the topic that you're studying. It's kind of this, it's a connection. It's really a connection, and for me, it's like being allowed a glimpse of the miraculous.
Spring of 2004. Cassini is closing in on Saturn. But just before contact, mission planners calculate a precise course to send the spacecraft past Phoebe, Saturn's outermost moon. Until now, all that scientists had seen of Phoebe is this picture taken by Voyager 23 years ago. But this time, Phoebe is in the crosshairs of Cassini's powerful cameras. Picture after picture returns with astounding detail.
We buzzed Phoebe. Okay, we came within 2,000 kilometers of its surface. You could reach out and touch it is what it looked like. So it's very exciting. We saw features that were 30 meters across.
The images of Phoebe reveal an ancient surface pitted with craters created over billions of years. But Phoebe is just an appetizer, a taste of what is to come. June 2004. At the Jet Propulsion Laboratory in California, NASA's team has piloted the Cassini spacecraft across 2.2 billion miles of space and is still right on target, fast approaching one of our solar system's greatest enigmas, the rings of Saturn. Very little is known about them.
The questions that we scientists have about Saturn's rings are the questions that an ordinary person might be moved to ask when first seeing them. You know, what caused them? How did they get there? How long have they been around? How long are they going to last?
Answering these questions is one of Cassini's prime objectives. A good opportunity for close-range observation will come as Mission Control maneuvers Cassini into orbit around Saturn, because that means passing right through the rings. Voyager revealed that the rings are made up of rock-hard ice, ranging in size from a grain of sugar to a large house. The rings, just 300 feet thick and a vast 38,000 miles wide, are chaotic and dangerous.
All the ring particles, billions and billions of them, are in orbit around the planet Saturn, and they're moving at quite a clip. something like 10 kilometers per second, faster than a high-speed bullet. If you were in Saturn's rings, you would be in a mass of particles that were bumping into each other and rolling over each other. If you were a ring particle, you would get bombarded from one side and then from the other as one particle bounced off of another all around you.
Entering directly into the rings would be suicide. But NASA's JPL team has a plan. They calculate a course for the spacecraft through a 15,000-mile gap in Saturn's rings. Even so, with one small miscalculation, Cassini could be torn apart.
Even a very small particle could be the end of Cassini. If it hits a particle as small as a grain of rice, that would be enough, because of the high speed at which it's moving, to end the mission.
But particles from the rings are not the only danger that Cassini faces. It also has to slow down. That means firing up its main engine. Any malfunction, and Cassini will simply fly past Saturn, lost forever in the void of space.
That engine have not been used very frequently over a period of 7 years. It makes you nervous. You know, it's like you have a car, a brand new car that you put in the garage, and every once in a while you turn it on, and then you have an emergency and you get in the car and you turn it on, it better work.
June 30th, 2004. The press gathers at JPL for news of the most critical part of the 7-year trek across the solar system. The ring insertion maneuver begins at 7:36 p.m. First, Cassini rotates to use its giant antenna as a shield to protect it when it passes through the gap in the rings.
You can imagine how anxious some of us were, knowing that it all hinged on one 90-minute period where we would have to perfectly just slip into orbit.
All eyes are on a radio signal being sent by Cassini's auxiliary transmitter. If the signal continues, then flattens out at the bottom of the graph, they'll know that Cassini survived. A $3.2 billion mission and 14 years of work all hinge on this one moment.
The Doppler has flattened out.
Cassini has arrived. When the images return, Saturn is revealed as never before.
I just don't know what to say. I'm kind of speechless.
Oh, absolutely exciting. I mean, this is a culmination of 22 years of effort and just seeing the Lord of the Ring in its big glory. We are amazed about the detail that we are seeing and the sharpness in the rings. You wait years to have this kind of a moment.
These remarkable images begin to provide new clues to some of Saturn's oldest mysteries. What are the rings made of? And when were they formed? Since Voyager, scientists have known the rings are composed of rock-hard ice. Cassini is revealing far more about